All right, this is the Unit 3 review for Math 137. I'll be doing a few problems through the review, just a little of each type. We'll not be doing every example this time, so just if you have any questions about any of the other ones, let me know. So we are given that indicated parts of a triangle ABC have gamma as a 90-degree angle, so we know this is a right triangle. Remember, gamma is usually at vertices point C. We'll have our A and B for our other two vertices. And then we know that alpha is 30 degrees and that B, little b, is 45. So because of 30 and 90, we know that this other angle here has to be 60 degrees. So that's what beta is. And because this is a 30, 60, 90, we can figure out the relationship of all the other sides. Typically, when you have a triangle that's 30, 60, 90, this is just kind of a reference point. Let me erase that and put it a little closer. You typically have the setup that whatever's across from 30 is, remember, 1/2 of the radius, which here would be 1, and then this is square root of 3 over 2. So if you're trying to figure out what this relationship should be, we have to think, okay, well, if this is square root of 3 over 2, how would we work back to find the other two sides? So the way that I like to think of this is I actually set the 45 equal to the square root of 3 over 2. And then I ask, well, if I want to find the side across from 30, I need 1/2. So I need to turn this side into just 1/2. So I'm going to multiply by 1 over the square root of 3. So then that would cancel, and then I would have 1/2 equals 45 over the square root of 3. So that's going to be the length of this side, but we would rationalize that. So 45 square root of 3 times square root of 3 is 45 square root of 3 all over 3. So that reduces to 15 square root of 3. So that's going to be the length of this side. And then whatever this side is, remember this is always double it. The hypotenuse is double the side across from 30. So if we double that, that would be 30 on the square root of 3. So there are all my sides using my 30, 60, 90 triangle. Okay, we're going to look at 7. So it says a rocket is fired at sea level and climbs at a constant angle of 65 degrees through a distance of 20,000 feet. So here's sea level. We have a rocket that's being fired. That's the rocket's path. It's a 65-degree angle. And we want to approximate the altitude or height of that rocket. So what we know is that, and this is 20,000, that's how long the rocket's been traveling, feet. So we know 65 and h and 20,000 have a relationship. This is opposite to the angle, and this is the hypotenuse. So if we do sine of 65 degrees equals the opposite over the height, we should be able to multiply both sides by 20,000 to find h. So if we type that into our calculator, we'll do sine of 65, make sure you're in degrees, times 20,000, sorry, too many zeros, and that equals 18,126, and we're supposed to go to the nearest foot, so that would still be 26. So 18,126 feet. So that is the approximate altitude of that rocket. Okay, we also want to look at number 6, just a different version of the part 1 question we did a minute ago. So this is another 90-degree triangle because of the directions above, and A, B, and C we'll label as so. This is B. Little a is for square root of 3. Little b is 12. Now, because this is a square root of 3, I'm seeing that probably means that we're going to be dealing with the 30, 60, 90. And the way you know which one is 30 degrees is it's always the smaller side. So we need to check if 4 times the square root of 3 is bigger or smaller than 12. And that's 6.92, so it's smaller. So this is the 30-degree angle at A. So alpha is 30 degrees. That means beta is going to be the 60-degree relationship. To find our other parts, well, usually we can do the same thing here. Well, we already have enough. So this is our 30 degree, this is our 60 degree. The 90 degree is always double the 30 degree. So this is going to be 8 square root of 3 for little c. Okay, that brings us to number 9. We're going to find all the missing pieces of this triangle based on what we're given here. So we're going to draw the best we can what this triangle looks like. And again, it doesn't have to be perfect. So alpha is at that angle, beta, and then gamma. Alpha is 27.4 degrees. Beta is 54.3. Little c is 97.1. So typically when you have two angles already given to you in the triangle, the first step is to find the third angle. So gamma is going to be 180 minus the 54.3 minus the 27.4, because in a triangle all three angles have to add up to 180 degrees. So we'll subtract those off, and that leaves us with 98.3. So that's this angle right here. Now that we have this, we can use the fact that we know the side across from 98.3 degrees. That means that we can incorporate the law of sines, because we know at least another angle or a side other than that. So then we're going to look at setting up sine of 98.3 degrees over 97.1 equals sine of, let's look for little b. So we'll do 54.3 degrees over little b. By cross multiplying, we would do 97.1 times sine of 54.3 degrees, and then we'll divide that by what we get when we multiply the other diagonal, which is this sine of 98.3 degrees equals b. So then we look at this. This is 97.1 times 54.3, which is a sine. And then we'll divide that answer by sine of 98.3. Hit enter, and this is approximately 79 point, I guess we're going to one decimal, so 0.7. So B is approximately 79.7. Okay, so then we need to do the same thing to find little a. So we'll do sine, again, of 98.3, might as well use the same one, over 97.1 equals sine of 27.4 over a. I'm just going to go through the cross multiplication real quick. This would be 97.1 times 27.4 sine divided by 98.3 sine. Hit enter, and we get 45.2 for little a. So we have our 98.3 degrees. That was gamma. Then we have 79.7 for b and 45.2 for little a. Make sure smallest angle is always across from smallest side, middle angle is across from middle side, and largest angle is across from largest side. Otherwise your triangle does not make sense. Now when you had two angles, you didn't have to worry about the cases where you might have more than one triangle. So we're going to look at number 15 because when you have an angle and you look at this, you say, okay, is it possible that there's two triangles? Well, the angle, if it's obtuse, it's the only possible obtuse angle you can have. So that means that you're down to one triangle or no triangles. If the angle is acute, like in 12 or 13, you would have to consider sometimes two cases if your sine that you're solving for is between -1 and 1. So depending on what information you're already given, if you know an angle is already obtuse, because there's no way you can have two obtuse triangles or two obtuse angles in the same triangle. So we're going to do 15 just to show you one where you only have one angle. But in this scenario, we won't need to test for two different triangles. So we have A, B, and C. We're just kind of drawing them however we want. This is 97.7 degrees. 16.7 is across from the big B, and 12.9 is across from the big C. So again, it looks like I can use law of sines because I have an angle and a side across from it. So we'll do law of sines by doing sine of 97.7 degrees over 12.9 equals sine of, we're going to be finding beta this time, over 16.7. So we cross multiply, that'll be 16.7 sine of 97.7 degrees over 12.9 equals sine of beta. And then divide that by 12.9. And notice we get 1.282 dot 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 dot. So sine has to be between -1 to 1, and this is not. So that means there is no triangle that exists with these characteristics. Okay, next we're going to look at this word problem about a plane flying between two airports. So a plane is observed flying between two airports, so we're going to label airport 1, airport 2. And those two airports are 17.5 miles apart. The first airport has a line of sight with the airplane, which we need to draw somewhere in the air. Ooh. And I'm not a good drawer, so this is your airplane. But if the angle of viewpoint is 57.2 degrees, the other one has a line of sight that is 41.6 degrees. We want to know what is the height or altitude of the plane relative to the ground right below it. So we're looking for this h. So this is on a problem where we can't just jump straight into this height. We're going to use this big black triangle to help us figure out one of the sides that we're missing, and then we can make a right triangle out of one of the smaller triangles to find h. So I'm going to start off with the fact that I know that the big triangle has 3 angles, and I already know 2 of them. So if we do 180 minus the 57.2 minus the 41.6, we get that the angle up here, all the way across, not just one of them, is 81.2 degrees. Okay, so now I can use, because I know an angle across from a side, for the big triangle, I can use my law of sines. So sine of 81.2 degrees over 17.5, which is the whole side of this part of the triangle, I'm going to solve for this one over here. I'm going to call it x. So then I would be using not the 41.6 but the 57.2 because it's what's across from that big x. So sine of 57.2 over x. When we cross multiply, we would have 17.5 times sine of 57.2. That's the first diagonal, and then we would be dividing by the sine of 81.2. Typically, when I'm not going to be done with a problem yet, I like to round out more than the decimal points that they tell us to, just to make sure I'm not getting too far off with my rounding from the beginning. And then we'll times that by the 17.5, and then divide it by the sine of the 81.2. And I'm getting 14.8851 if we round to 4 decimal places. So 14.8851. Okay, so then this triangle right here is now a right triangle, so we can just use regular trig functions. 41.6 is opposite to h, and this is the hypotenuse. So we can use sine, just a regular sine relationship, to solve for h. No law of sine, just this is a right triangle, so we don't need law of sines. So we'll multiply both sides by the 14.8851 to solve for h. So 14.8851 times sine of the 41.6 equals 9.88 if we rounded 2 decimal places. If you had rounded too early, you would have gotten, and this is in miles, by the way, you would have gotten 9.89 because you rounded up too soon. So that's something that can get you on points. Okay, the next one I want to do, because we did a lot of law of sines in class already, and we did some in some of the problems we've done so far, I want to make sure we do at least one of the law of cosines. So we have 3 sides of a triangle. So A, B, and C. And we have that little a is 28.3, little b is 32.4, and little c is 49.9. Okay, so we're looking at this as we don't know any angles, but we do have our law of cosine formula that'll help us find one. So typically, what I like to do when I'm trying to figure out which one to solve for is that I like to find the biggest angle first, because then if it's obtuse or we know there's no other possibility for a second triangle. So we're going to try to find gamma first, because gamma is across from the largest side. So the formula for this is the angle you're trying to find, remember, is going to be the one that's attached to cosine. And then the other letters, the ones that are kind of cradling that, in other words, this is the included angle, so little a and little b, little a, little b, those are going to be on the side of the formula with that. So remember, the formula would be little c squared, because that's across from gamma, equals a squared plus b squared minus 2ab cosine gamma. So then we plug in what we know. So C is the 49.9 squared. A is 28.3 squared. Plus B is 32.4 squared. Minus 2 times the 28.3, also times the 32.4, and then cosine gamma. Okay, so we're going to have to work this stuff out. You can write it all out, or you can just work it as you go. So 40, I'm going to move these two guys over to be with this one by subtracting. So 49.9 squared minus 28.3 squared minus the 32.4 squared, that's going to give me 1,049.76. So I'm subtracting both of these over to the other side. That's how I got this. And then I would still have this negative 2 times 28.3 times 32.4, and that's negative 1833.84. 0.84 cosine gamma. And then I need to divide over this, so it's going to be 1049.76 divided by negative 1833.84, and that's cosine of gamma. You want to double check to make sure that's between negative 1 and 1, since cosine also has to be between negative 1 and 1. It should be, but we're going to double check. So 1833.84, and it's negative. Oops, too many threes. 0.84. There we go. So yes, that's between negative 1 and 1, so now we can take the inverse cosine of that. So I'm getting gamma is 124.9 approximately. The reason you want to find the largest one first is, especially if this ends up obtuse or 90 degrees, you know there's not going to be a second case for another triangle because you've already had an obtuse or a right angle. So then we can find the other parts by law of sine. We can find, let's say, beta next. So I would use law of sines now using this angle. So sine of 124.9 degrees over the 49.9 equals sine of beta, which we don't know, over the 32.4. Go ahead and do our cross multiplying. So 32.4 times 124.9 as a sine, and then divide that by the 49.9, and that is 0.5325 blah 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 blah, and we want to do inverse sine of this. So 32.2 And I don't have to worry about another angle because we already have an obtuse angle in our triangle, and you can only have one. And then just to find the other angle, we can add the two angles we have and then subtract from 180. And that would be 22.9. I know mine was negative, but I subtracted the wrong way. So now we have all of our angle measurements. Except I think we just had a boo-boo on this one. Sorry, I looked at the answer key, and I don't think I fully subtracted when I was moving things over, so let's go back. It'll be an easy fix, but just something you have to be careful about when you're doing your calculator pushing, because I did not hit enter after I subtracted all of those squared parts. So it's actually 639.36. Okay, so let's fix this. So this part right here was 639.36, which is going to change my angle here. So let's double check that. So then divide that by the 1833.84, which is negative. Then take the inverse cosine. And this is the correct angle. It was supposed to be 110.4. So this is 110.4. And then we have to fix that here. The process is still the same, it's just I did not get the correct angle for the first one and it messed up all the others. So it's really important that you double check, but it's also like most instructors will say, okay, you did do a lot of the work right, you just had one part wrong, but you don't want to lose points, so let's just fix this. So 32 times 4, and then divide it by the 49.4, and that gives me the sine inverse I have to do. So that's 37.5. And then we subtract the two red ones from the 180. So 180 minus 37.5 minus 110.4, 32.1. So you just have to be really careful, especially if you take any shortcuts like I did. I didn't write out all my steps, and that's, something that is more important is writing out all of your steps. So those are the three angles we should have gotten. And that's going to be the end of part 1. I'll do a few more problems for a part 2 and get that out as soon as possible.